And I think we're live. See? Yeah, awesome. Okay, welcome. Today we're going to do day, what is it? 12 already of Advent of Code. Let's just make sure everything looks fine. Stream looks healthy. Okay. Hot springs. You finally reached the hot springs. You can see the steam rising from secluded areas attached to the primary Allnet building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. I don't know what onsen is. Hot springs, bathing facilities. Okay. The hot springs are next door. You look in the direction of the researcher is pointing. Suddenly, you notice a massive metal helix. The massive metal helixes towards towering overhead. This way. It only takes you a few more steps to reach through the main gate of a massive fenced-off area containing the hot springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they're not very hot right now. We're having a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, all of the gear island is currently offline. Nothing is being manufactured at the moment. Not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation, but we should be able to find the one springy enough to launch you up there. That kind of hot springs. I see. um, um, there's just one problem. Many of the springs have fallen into disrepair, so we're not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged, your puzzle input, are also damaged. You'll need to help them repair the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it has an operational or damaged. It is operational or damaged. Okay. This is the part of the condition records that is damaged. Is itself damaged. For some springs, it is simply unknown whether the spring is operational or damaged. However, the engineers that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed. Of each contiguous group of damaged strings is listed in the order of those groups appear in the row. This list always accounts for every damaged spring. And each number is the entire size of its contiguous group. That is, groups are always separated by at least one operational spring. Okay, so spring at least one operational spring. So for hashes would always be 4, never 2, comma 2. So the condition records with no unknown spring conditions might look like this. Okay, 1, 1, 3. Okay, makes sense so far. 1, 1, 3. Okay. More examples. However, the condition records are partially damaged. So what would this look like? So we'd have actual unknowns, and then we'd need to find like a solution satisfying everything, right? Okay, equipped with this information, your job is to figure out how many different arrangements of operational and broken springs fit in a given fit the given criteria in each row. Interesting. So there is okay. So for the first line, there's exactly one way to order the groups. By the way, and yeah, that's because they are strongly ordered basically. So and the second line is more interesting. There could be a total of 4 different arrangements. And why is that? Because yeah, one of each thing must be a thing. Okay, that's kind of making sense. To satisfy the final contiguous group of the 3 broken springs, each blah 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 blah. Okay, yeah. The last line is actually consistent with 10 different arrangement because the first number is 3. Okay, so yeah, there are a lot of a lot of combinations basically. In this example, the number of possible arrangements for each row is 1, 4, 1, 1, 4, 10. Adding all of these up, counts up to 21. For each row, count all of the different arrangements of operational broken springs that meet the given criteria. What is the sum of those counts? Okay, and this is a good time to look at the input. So these are all quite short, not particularly short. So we could actually scan them and try to figure out like the possible things. And this is a kind of like a caching dynamic programming thing, maybe. We could like do a divide and conquer basically for all of these, and then we could figure out how to split everything up. So how would we approach this? First of all, this is maybe a good time to use Python and not Rust, because this would not teach me about Rust, and I will suffer immensely. So I say I'm gonna Python this one. I think that's going to be a very responsible decision, given that I have quite less time today. So that's going to be PyCharm today. And I will definitely not regret choosing Python for this. So apparently every multiple of 6 is going to be a Python day. So new Python file. Wait, Py, yeah. So let's just copy this one. That's going to be day 12. And what are we actually? Okay, so I haven't copied actually anything, so whatever. Let's start with actually testing this one. And then we would actually do the fancy stuff. So where's like the damaged record? So we've got this one as our input, and we've got this one as okay. So this is going to be our input. So input is going to be this one, or yeah, part 1 test input. Now let's figure out how do we actually do this. So now we've got everything set up. We would like to find possible arrangements. So first of all, we need to split that into lines. So we could already do strip and split lines and keep ends false. Okay. I think keep ends is line breaks are not included in the results. Unless keep ends is given true. Oh, I see. So we don't need to do this. Okay, so we've got our lines. What are we actually going to do about the first part? We are going to basically we need to return an integer, but let's think about each line. So def possible arrangements. That's going to be a function that receives just one line. That's going to be one string. Then the possible arrangements of arrangements of we've got of is it the damaged springs? No, that's the working springs, right? Of damaged springs and operational one. Okay, so of operational and damaged springs. Operation. Operate. Okay. So firstly, how would we actually do this arrangement? So we've got basically an enum of operational, unknown, and whatever. So all we know is, first of all, we need to split everything up. So what would that be? So let's actually just have that as an enum. So class. How would we want to pass that? Would like basically no, so much junk. Yeah, okay, so class string, okay, condition, let's call that condition, and this is going to be an actual enum. We might not use that, but we've got operational, that's going to be dot, we've got damaged and unknown. Okay, and we do want to split, so we do want our cats. So first of all, let's actually do that. We've got possible arrangements of a line. That's going to get our damage count. That's going to be counts. That's going to be line split on this thing, split one, take that, and that is going to now be split on comma, and we do want to convert that into int, so we say int on whatever this thing is, so that's going to be some kind of n for n in this thing. So damage count. Let's just have that like as a small assertion thing. So we've got def damage count that's going to receive a line of string and return us a list of ints. And that is going to be this thing. For n in thing, we could assert that damage counts on this one. Yeah, basically Copilot did the testing for us. That's very nice. So we've got our damage counts. We could obviously cache that because we would like to cache things because, well, a lot of things would be important. Like we would need to cache a lot of things, probably. I don't know. So we've got that. Counts, that's going to be damage count. And apart from that, we now need to actually think about possible arrangements. So let's actually have like the conditions. That's going to be a list of conditions. So let's have another one, which is def conditions. That's going to give us a list of conditions, and yeah, that's going to be this thing. Seems legit. So caching as well, because we are going to do a lot of crap here. So we've got counts and conditions. Now we need to actually start and find like possible arrangements of each thing. So how would we do that? Cool. So instead of actually keeping everything in these small groups, we would probably want to keep that. Ooh, interesting. So instead of actually like splitting everything up, we could actually only split on the operational ones, because keeping a split on that, I mean, because basically we correlate the unknown conditions with actual arrangements, and then we can split on that, basically. I'm not sure I'm very okay. Never mind. I'm gonna yeah. We could split on the dots, basically, and then we need to like, and then we can divide and conquer. We can match like a group with whatever like group, a group of 3 with this group of hash symbols. And then we could divide and conquer the other part. So I think this is going to be our way to basically divide and conquer everything up, and then we could at every time try to match up our thing with our question marks with um, uh, like the damage, like the remaining group numbers that we've got. So let's try and do that. First of all, we can we could do this. We could say, first of all, instead of like damage counts. Okay, so we've got that. We do want our conditions. That's going to be, well, I'm gonna comment these out for now. And conditions are going to be just line split thing 0. Yeah. And now we'd like to correlate everything. So how do we split that up? We could split on dots, exactly. So splitting on dots would give us empty things. And node stir split is mainly useful for data that has been intentionally delimited. Okay, sure. Is intentionally delimited. So we've got that, and we've got our conditions. And now we can try to match these up. So how do we do that? Hmm. So I would probably want that to have, okay, so I think we should obviously have our counts here, which is, as we said, that's going to be a tuple of int, because passing tuples is going to, and passing tuples or lists. I think, okay, a list of ints here is going to be important. Then at the first time, that's going to be actual, okay, if it's none, let's just do that. So it's going to be a list of ints or none. Okay. And obviously functools cache on that. We are going to be, and now counts are going to be either counts or computing them again. I think that's going to be the thing. So you know what? No. Okay, so this is already, that needs to be the conditions already. That also needs to be the list of stirs. And we might want to change that into something else, but for now, list of stirs is going to be good enough. Or you know what? We could actually, if it's going to be a list of ints, that's actually going to be more useful because that means we can we can match up ints for ints. We don't need to think about anymore about symbols and strings. So we could split that into ints. So yeah, okay. So this is going to be our list of conditions. And we could, and how would that look like? We could start with something very, very simple. So possible arrangements of this thing. So let's start with a very dumb assertion, which is this is not a thing anymore. So that's going to be a list of ints as well. We could actually process that. A list of ints. So that is going to just be line split this. That's going to be just the first part. And that's going to be split on dot. And then we say so len group but how would we all we'd have is either groups of size unknown, and then that is the thing that we need to do something about. So we need to preserve like the unknown condition. So that is, let's think about that. We've got our, and also that means so we would need to split things differently every time. Interesting. So yeah, okay, so let's just keep that as a group. So apparently just this. That's going to be a list of stirs, and we need to think about that a little bit more. So we got that. And we do want to pre-process everything. So we should say possible arrangements of list of stirs and list of counts. So let's try to think about that in a minute. Okay, so firstly, let's start with dot. Okay, so assert. Possible arrangements of thing, that's going to be 1. Yeah, that's actually a good thing to try and figure out. Or you know what, let's actually start with something very, very simple. I mean, that's simple. Yeah, so dot and possible arrangements of just dot. And we do need a list of just 0, I think. That's we've got that's operational, so we don't have have an empty list. The possible arrangements of that is going to be expected hashable got list. Ooh, interesting. So that needs to be hashable. So tuple it is. And tuple. So that's going to be a tuple, and that's going to be a tuple as well. And this one obviously fails because we haven't done any thing. So if counts is not none, so if we don't have count, okay, if not counts, return one. Okay, so that's going to now pass, of course. And now we've got another thing, which is got unknown and one. That's going to be another thing, but that's now going to fail on assertion error because none does not equal one. So how would we approach that? So if sorry, that's a tuple of strings, and we have split on that. So that should have been this thing. And that's going to be interesting. So I'm inconsistent with the thing that I say. Okay, so that's going to be an operate. Okay, so this is a better test now. So first of all, we've got if not counts, then that's just one possible arrangement. Doesn't really matter what it is. If not condition, that's going to be 0, I guess. So 0. Otherwise, we are going to return the sum of sum. Is that possible arrangements? So we do want to somehow know how to split things. Interesting. So how do we line these up? That's very annoying. Range. So, so how are we going to divide and conquer this? So we've got a question mark. What are we planning to do with this question mark? So if so the ones that are known, that's going to be a tuple of literals. I mean, I'd want something better than string processing. I want like grouping somehow. Hmm. So how are we going to extract this crap? Um, this feels like a regular expression, like all the possible regular expression combinations here, which is interesting because um, uh, I want to basically know what is the limit of the catastrophic backtracking, like what is like all of the ways for a regular expression to match something, um, which is very very interesting to think about it this way. Um, regex find all all possible matches. So refind iter. That is going to be, I want like basically all of the, not an iterator. No. I want all of the overlap and also overlapping matches. So regex, all possible overlapping matches, which is obviously like usually the backwards how to find overlapping matches with regex. Refind all L alone. So find all with look ahead assertion. Interesting. Find all doesn't yield overlapping matches by default. This expression does, however. So that is going to just maybe work. So what does the look ahead assertion does? What does it do? But basically, if I can compile this into a regular expression and we can just find all of the matches, then we know their count, which is overlapped. Ooh. Oh my god, that seems to be maybe like a savior. So let's try add regex and sync. Now back to this thing. Import regex as re. That's going to fail because we haven't told things. Wait, what? Why is it unhappy? It says reusing existing virtual env. It's saying did not run successfully. Preparing editable metadata. Actually, build target. For example, this is intended to ship a directory named foo, which resides in source. Wait, what? Hi project normal. Foo. There is no foo here. So we got this thing. Add your description. Build system hatchling. Do we need to put like, do we need to have a source directory, I think? So let's just add it quickly. So we've got pi, and then we should say source. Oh, wait, here. So let's just have under init, just something, basically. Pricing. Still unhappy. Why is that? Why are you unhappy? Module has no prepare metadata for build editable. Interesting. So fuck that shit. Dash and pip install regex. No module named pip. And that is, why is that? Because it's all about that thing where do we need to have like another thing here, which is a module basically. So let's have, wait a minute. So we've got build system. Seems like a waste of time. Sorry, up. Unrelated stuff. I would resort to just using the thing without wait a minute. Okay, I'm just installing pip, installing regex, and we are moving on. I'm not debugging that right now. Okay, so we've got our regular expressions. Then we go back to this amazing overlap thing. So re-find all overlapped. So let's actually find all of these combinations. I think that would probably just be the right thing. So we just need to build our own regex. So now we've got our counts. We don't even need to do anything fancy about our condition right now. So we just need to compile our pattern. So pattern, that is going to be, well, so we've got basically, how would we join that? So we would like to join that on dot plus, not dot, slash dot, plus. This is our joiner, basically. And we would like to join that on a list of, we are going to format that. And that the format is going to be this thing. Then we've got the 0 through count. So, exact count. So that's going to be counts or count and counts. Okay, so this is our matching, but it might not be this thing, because this would match on a valid record, not on an invalid record. How would we want to do that? So this is our group size. And this needs to be not just, that's that possible, by the way, to do that? I mean, we could say recompile around this and might suddenly feel to be okay. No. So we've got, we could maybe, let's try to like recompile this thing. Still no. Oh, no. Okay, no syntax highlighting for us. Anyhow, so we've got this count might be a count or a question mark. Can't be a dot. And this one must be either exactly a dot or a question mark. I think that's it, and question mark. So let's try this pattern. So we've got recompile this one. Firstly, let's just look on how it looks, just to be like sure. So we've got our pattern. Let's just compile that on something. So print recompile on a tuple of just 1, 1, 3. How would this pattern actually look? It looks like hash or question mark repeated once, and then dot or question mark repeated exactly once, once or more, and then hash or question mark repeated once, blah, 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 blah. And now we could try to assert that this pattern, so we've got this pattern now, which seems to be somewhat legit. Why are we not using black? Let's use black. So we've got black, binary, on save. Let's reformat that. Oh, that's much nicer. So we've got our pattern, and we'd like to just match that on the string. So we've got our counts and thing. So we could actually just split that back into the thing where we say conditions and tuple is condition and line. There are no do need line. So, and condition is going to just be nothing fancy. No. That's just literally line, split, space, take the first one. Exactly one split. So this is our conditions. We do not need this one. We might want to cache that one now, but I'm not sure. Actually, we do want to test damage counts. Sorry. That is actually important. So we do have that one, and it says that we need to actually start something and say something. So would now assert that possible arrangements is 1. And we've got an exit code, and it says assertion error, and that's because we said print pattern, we didn't say length find all. That's going to be exactly 1, but that's overlapped true. Now let's actually test all of these. So we've got multiple tests, so let's actually hand them over. So let's now let Copilot do the thing where it asserts for us. And let's run that. And it says exit code 1 on assertion error. And I mean, we might want to do this in like PyTest, and then we'd have like nicer assertions. You know what? Yeah, let's just call that test day 12. Add def test possible arrangements. And that is going to just be thing. We shift it over. And we do want to install PyTest. So PyTest. And suddenly we've got our runner here, which is very nice. And now we've got an assertion. It says module py has no attribute path. And that is probably because we are missing, oh, we do have it under init. Interesting. So who's unhappy and why? So let's call that now test. Push that over here. And now that we've got that, let's try to rerun that. Or you know what? Actually, outside of Py. Let's literally have this just outside. So refactor move and PyTest. Amazing. So we've got 2 equals 4. Interesting. So let's now debug our regular expression. So it's on which line? We are on the second line. So why would that be? Because we haven't done the thing which we claimed that we would do, which is to do the forward assertion thing. So this should have oh, we should have just said overlapped. Interesting. So we could use refind alls this thing or use the thing. Okay, so let's try this. So we could say what's going on? Why is my computer grinding? So wrapping pattern. That's going to be so we've got this thing and need to pass that. Then instead of like actually can format that into the thing. So we could say format our pattern. And we'd want to wrapping pattern. Oh, sorry, recompile this wrapping pattern and try that now. So equals this thing and find all. Let's try that. This one is now still, oh, let's just use PyTest directly. It still claims that this is not matching correctly, which means that I need to think about things. Oh, it could be this thing. So it could be, instead of plus, it should have been non-greedy. And that would mean that things could like catastrophically backtrack. And we do want that. So PyTest. And we've got still 2 against fall. I do want to debug the pattern, so print wrapping pattern. So our wrapping pattern is now is it 113? By the way, yeah, it is 113. So let's look at the wrapping pattern. So we've got our forward assertion, which we need to figure out if we did that correctly. I think we did. Oh, I see we should have added another group. Interesting. So we should have added another group. And at this point, we don't even need to use the whole overlap thing because, well, we've done the forward assertion. So let's try that. And it still claims that this is not true. Okay, so let's figure out what have we missed. So this should have matched on the first dot, be greedy, and not greedy, like at the first dot and stop, because it's not greedy, it's not possessive. And then once that has matched, it should have matched on exactly one thing, right? So yeah, it should have matched on. Oh, there is no dot in the first. Okay, there is no dot in the first spot. So that's interesting. So we should also have another empty one. So that's going to be a non-possessive ending thing. And we want another non-possessive thing here. And I think that should be better. Okay, so we've got 3. So we're not done yet, but we are getting closer. So let's look at the pattern again. And let's stare into it very, very well. So we might have the first question mark. Okay, so we've got the first dot we don't know if exists or not. Then we've got our first group, which is of size 1. Then we've got another group size which must be at least 1, but we don't know which on or how or how many. Let's just try to use now the overlap true. So find all. Is that like the thing? So if we go here and we say from.regex find all, overlapped, not overlapping. Overlapped. Let's run that. Still the same assertion? Yeah, okay, so we should continue. So let's continue with trying to debug that. So we've got either, so this is like the ugliest regular expression of all times, but it's actually, it might be actually the thing that we aim for. So we've got, yeah, the first one, which is possessive on dot, or not possessive, everything should be lazy. So we've got an optional group at the like at the start, and then the first group, which is of length 1 exactly, and then we've got our first separator, then we've got our second group, then our second separator, then our third group, and then another non-possessive separator. So how come this does not match what we expected to? Let's think about that. Let's actually, you know what? Let's, instead of like printing the length, let's actually find all of these combinations, and then so we do. Let's just print them all out. So we've got combos is going to be p find all on that thing. We say combos, and then we return the length of combos. And we say pytest -s, I think, in order to not catch things. -s. So we've got captured standard alcohol. Okay, so why do we got, that's the wrapping pattern. Oh, I see. These are like the different groups. So here we've got, oh, it's I see, it's always going to be, basically, it's going to look the same every time because it's not actually showing us the capture groups. So in order for this to actually find the capture groups, we could, instead of like returning the strings, let's how would we want to do that? I want like to find all the actual match elements. So find iter, I think that's going to give us that. So let's do find iter. And then that's going to be, I want to list all of that, all of these. And let's try that. Would that give us, yeah, that's going to give us these spans. Okay. So how would we want to print these spans? So we've got, oh, we do want like the actual groups. So we do have a way to do that. Let's actually find these spans. So we've got this thing, and we do want this thing, and we do want each of these separators. So we've got these, and now we should have all of these goddamn spans. And let's try to like formalize whatever this crazy thing is. So we could, instead of like actually just printing the combos like that, we could try to print out something nicer, which is these are matches. So that's going to be a match for match and combos. And since this is a match statement, let's does it maybe say what did it match? So it does not. Interesting. Oh, it only shows me not the right thing. Let's try to import re. It said overlap is an invalid keyword, and that's okay. Find ita. So I don't think we need the thing here. I think you're okay. So we've got this big group which we don't care about. And then within that group, we've got a lot of like small separate groups. So let's try to look at this pattern now. It says overlap 3. Oh, but we've got matches, so that's nice. So how do these things look like? So we've got, by the way, are these actually dots? Let's just make sure these are actual dots. Still same thing. Um, so I want these I want the groups, not the actual match. Interesting. So instead of like printing the match, let's actually do dot groups. I think that would work maybe. And we've got a groups match object. Okay, so we need to list them out apparently. So list, and let's p-print that because, well, it says p-print dot p-print or not iterable. Wait, what? Oh, so groups dot what? Built-in method. Ooh, I see. Should have been a function. Okay, so we've got our matches. So let's look at these matches. So we've got dot, question mark, dot, 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 question mark. And I'd want to actually replace that with a thing, but I'm not sure how would we actually do that. But this does look very good. Let's see which combination was missed. So this combination was missed. At some point, this should have been so let's look at that. So this is always captured together, and that's okay. And this should have been empty. Wait, what? Why is this not actually capturing? Oh, because it's always lazy. So does this need to be possessive? Yeah, this can be possessive. I see. Like the last one can be possessive. And now this would match the same thing, but would give us the dot here. We're not missing anything. Oh, I know what we could do. We could say, instead of, we could say that this can be not possessive, but also this needs to be a dollar, and this needs to be start. And that's going to match on everything. And why is that now failing? Because it's part of the capture group. Should have been outside. So outside. So apparently not. Okay, so never mind that. So these must be continuous sequences. This is like nothing that we can change here. I think also instead of like doing, let's actually do this and actually interpolate count in. I think that's going to be nicer looking. So we could say format and then format count. I think that's going to be a little bit more readable. Not very readable, but no possible arrangement. But okay, so never mind. Apparently, I don't know how to string format, so let's bring that back. PyTest. So what else is missing here? So this one should have matched for more combinations, but it didn't. This should have matched on empty twice, and not on empty, on the dot twice. I think. So how can we make that work? Let's try to make it non-possessive. And then we've got, like extremely possessive, basically. And we've got three, but three different groups. So I want both of these, basically. I want possessive and non-possessive behavior. So let's apparently do two regular expressions. Oh, you know what? We could actually do that. We could literally do this all thing. So we could say it's either possessive or non-possessive, and let's see if we've got 4. We don't. Interesting. So it's either possessive or non-possessive. So okay, let's just do this. So we've got greedy, and we've got non-possessive. Non-possessive. I'm sure there's a way to pause that. Whatever, I don't care. So this one is going to be this thing. So we've got 2 patterns, basically. And we are going to add them all into a set. So that's going to be a so these 2 patterns together should give us both like the actual things that we aim for. So let's do that. We've got, so our combos are going to be, first of all, we should have compiled and matched everything. So let's just do that. We can say chain, so itertools dot chain of 2 things, which is the compile on the greedy pattern, find a chain from iterable. Oh no, that's good enough. So find iter on conditions overlapped equals true, and the same thing for the non-possessive pattern. And we chain them all, and we just need to then we return the set of these, and we return the length of the set. Return the length of the set. And this is quite difficult, but we could try that. So let's run that, and we've got find iter, and we've got an assertion error. We say the first one now has 2 different ways to match, which is interesting. Very, very interesting. So let's try to do that with PDB, and you know what? Got this set. And if we now print that, we might have like the locals. So verbose and no locals, please. RG verbose. So -L. Oh, this assertion is, it's not here. I see. Because that does not give us the thing. Okay, so sure, let's just return the set. So we could return S directly. Let's inline that. Then we could say the length of, that's still gonna suck. So wind that back into the length. I do really want the set, so let's breakpoint that. So S. Oh shit, S is a reserved word in PDB, so that needs to be combos. So we run that again, then we say combos. Then we've got two match objects, which are not different. I see, because this should have been find all and not find it. Find all, find all, find all, and quit, run, then combos. Exactly one thing. Interesting, but it is. Why is it doing that? We are chaining two iterables. That's correct. Sequence. So yeah, this is what I thought. I wanted to do this. We could say plus and then just add that here. And no comma here, just to be sure everything is kosher. Verbose, run. Combos. It's a set. Why is it a set like so? That's very annoying. So let's just have these. So that's going to be R1, and that's going to be R2. And I just want to see that in action. So that's going to be, for now, I know it's wrong, but the length R1 plus the length of R2. I know this is still wrong, but just I want something. Okay, so R1. Okay, so that is just incorrect. So this thing, for some reason, these things are not going to, not doing the thing that we expect them to. So we've got the counts, we've got the pattern, we've got this greedy pattern, we've got this thing. So so first of all, let's actually print the greedy pattern and print the non-possessive pattern to see that we haven't fucked up anything here. So that's going to be quit. Run that without PDB maybe. So no debugging for now. And we've got our pattern, which we expect to be okay. We say, yeah, so 1 equals 2, that's definitely incorrect, but that's because these things are not what we expect them to be. So let's run that again, verbose, and then R1. Why is it doing that? So we say find all, overlapped. So maybe we should do this. Let's try that now. And R1. Why is it a list of, oh, it's a list of tuples. I see. Okay. So it's actually splitting by groups. Okay, so that's actually a thing. Is it the same group though? So let's look at that. So in R2, just to be sure. So in R2 is definitely doing something different. Why is that? So, oh, because I added the group here. But didn't do that in the second one. So that's going to be verbose, and that's going to be R1, R2. And these ones are exactly the same match. Okay, so cool. Now that we've got that covered, maybe let's not do all of these capture groups because they are adding a crazy amount of like splitting and tupling and a lot of crap. So we do not want that for now. So we just say, yeah, we just have our pattern just like that. It was nice for debugging, but not nice for actually getting things done. So let's rerun this thing once more. R1, R2. Yay, two very, very similar matches. Suspiciously similar, one might say. So, and then we should say the length of the set of R1 plus R2. Then we can quit and pytest that. We can continue one assertion. Then we got the second one, and that's going to be R1 and R2. And they are going to have one of them slightly different, I think. Oh, we're not gonna know. Shit. Damn. That's the thing. We have to split it by groups because that's like how we measure uniqueness. So we do need the actual thing. So how would we do that? So we do not want the external group, but we do want every internal one. So that's one, that's one. And also here, we've got this and this one. And we've got this thing, which is our joiner, and we've got our count, which is the heart of the regular expression. And now we've got that. Let's actually pytest that. R1. Okay, so this is one thing. This is the second one. We can continue, and that's the same. R1, R2. That's going to be very hard to distinguish. But we do see differences, which is very nice. Now the question remains, are they actually going to sum up into the thing? No, and we've got 5, which is not good. So how would we know which group is which? Like if they all render out to be like the same logical group, then we would be fine with that, but that's not how we like it's hard to know. So first of all, we should if we drop empty groups, is that the way to do it? Is that like the way to join things? So we've got this empty group. Let's try to find all the unique things, and if dropping empty groups would make things work, then that might be it. So let's look at that. We've got dot question mark. I think that's the unique one from the possessive or non-possessive one. Then we've got question mark start. And this question mark start is not any other thing that we've seen here. Then we've got this one looks exactly the same. Yeah. And these ones are different. So yeah, okay. So first of all, let's just try to command F that. Oh, so these ones are also different. Interesting. So here we've got, yeah, dot question mark, and then here we've got dot question mark, question mark. How is this counted? We've got this is 3, then this is the separation, this is 1, this is the separation, then 1 separation. And that could also be, yeah, separation 1. Yeah, and then these should trade as well. So why are these not? Okay, so we've got a bug, actual bug in the regular expression, because these ones should have been sometimes that, sometimes the other, and that hasn't happened. And why is that? Because these are also not doing the thing. So this one should not be possessive as well, maybe? So if this one is not possessive, then nothing here is possessive. Let's try only the greedy pattern. So no R2, or let's just say R2 is just this thing. And R1, just one group, continue, R1. And we've got 3 groups, shit. Let's look at the groups though. So we've got, are these trading places? Yes, they are. Interesting. So what gives? Here we've got dot question mark. Here we've got question mark. Here we've got empty string question mark. So wait, this still must be start to end. Let's run that again. And here we've got R1, should have been just 1. That's okay. Continue. R1, just one group. Why is this like breaking the overlapping thing? That's very annoying. So this one must, like, this must never be a thing. So it's either an empty group or a plus, I think. So that's going to be this or nothing. But then I do not want to capture that group. So it needs to be in a non-capturing group. And then we say, I think that's the way to do non-capture. And then it's either empty string or something. Then let's actually look at that. Continue, run. So now we still get an empty group, which is annoying. Why do we get an empty group? Because this should have been... Oh, wait, no, but there is no concept of empty groups at this point, I think. There shouldn't be. But it does match. Interesting. So it matches with an empty group, and then therefore it must like exist in this greedy pattern, in this greedy capture. Not greedy, I mean in the capture, basically. So we've got this capturing. How can we make this work? So we've got question mark and dot question mark, and then question mark. That's the one. Wait, what? Line. So we've got dot question mark. That's okay. And then we've got either empty question mark. How come this is empty? This is not a thing. So it must be something or completely nothing, but then also not CAPTCHA. So I've got an interesting idea, which is to say start of line or this thing. Would this work? Would this force it to continue R1? Okay, this now has killed one of these. Interesting. So, and this, if we make it again like a star, is there like also there's I think in Python regex plus plus. I think there's like another way to do like possessiveness. Okay, so plus plus. Let's look at plus plus itself. So like the quantify, like the star plus and question mark quantifiers, those where plus is appended, also match as many times as possible. However, unlike the true greedy quantifiers, they do not allow backtracking. Interesting. So let's try plusing everything. And let's see if with this thing, so we've got either empty or plus plus. Sorry, either. So it's either. Oh, I see. So it could be star plus here. Then here, this should be plus plus, and then this should be star plus. And this one is exactly the same. So let's try that. We could just do this. Continue. Then we say 0. Interesting. So I test R1 empty list. Why is that? Let's look at the pattern. Quit. We do want to print the greedy pattern, so let's just do that quickly. So we've got L greedy. How does it look? So we've got star plus on dot. Oh, first of all, I see that we don't need this slash. The slash doesn't do anything fancy. So I test greedy pattern. And R1 is capturing nothing. So this thing is not what we expected to be. And why is that? Let's think about that. We've got this option. This first one is I've got maybe an idea. Maybe let's just pad everything with a 0 group at the beginning. And then, no, that's not good. Good at all. So let's think about that. Okay, so first of all, this whole star plus thing is not gonna is for now it's not working. Let's go back. Continue R1. Here we are back to the same thing. By the way, let's just arrange the test because we know exactly which one fails. We don't want to like do this whole assertion thing every time. So how does this look? Is there a way to overlap? No, they don't allow us that. So exception purge. No, that's not interesting. Regex Python. Pip. Then we go to this one. We go to the home page. Then overlapped. Permits overlap matches. What I don't like here is basically we don't, as we can see, we don't get like the guarantee of everything being overlapped, but that might be also like my problem, not theirs. So we need to make sure of that. So we've got our thing where we say now we run that, we say R1, we get that thing. Okay, so we've got the first capture group. This seems okay. The only thing that we've got here is interesting. So instead of, I wonder what happens if we completely disregard the edges. Just what are the overlapping matches on, sorry, let's not undo all nice work. Let's literally use the pattern itself with nothing fancy. PyTest, R1, 2. That's even worse. And why is that? We are joining on a one or more width separator, and this one is always matching on the first one, which is annoyingly annoying. Is there a way for us to, first of all, the problem is basically that we don't have a way to like throw the junk out. So what happens if we instead, let's try another junk pattern, and that is going to be basically anything at all, and anything at all. Would this please, like I want the catastrophic backtracking. And then we've got the same crap. So this one is matching on the right thing, but that's not what I want. Oh, I haven't used the junk pattern, sorry. So let's try that again. Got R1, which gives us 3 groups. And why is that? Because we've got either empty string on the first group and then dot. So can we match on like anything? I wonder. I wonder indeed. What happens if we go the very interesting route of saying instead of counts like so, we have a tuple with 0 width, then another 0 width thing. So these are now our new counts. Then we've got this would pad everything correctly. And then we don't need the greedy pattern. We've got our pattern, which we could print, by the way. Let's just do that. And then in order to match on that correctly, we'd want to also add a dot here and add a dot here. That would always like catch the first separator. I know this would tank performance, but I want something. 4 groups? No, just 3 groups that are larger. Good. Continue, yeah, 3, 4. And this one is, by the way, oh, sorry, this is now, yeah, these are pluses. Interesting. If we try to go the possessive quantifier route, PyTest, a 1, empty. Okay, so possessiveness does not do the thing. Or maybe it's Python 3.12 thing, and that's why we're fucked at the whole possessiveness. So let's go for Python 3.11 and then look for plus plus, and there is no plus plus. Oh, there are plus pluses to be found. Okay, so just no, basically. Interesting. Maybe what we would want instead of that is, okay, so I'm trying to think about things. So let's do this. We've got this one, then it could be any amount and any amount. And again, this is because I want the catastrophic backtracking. I really want it. Really want all the ways to match. Then we run PyTest. Then we've got R1, and it is still terrible. And let's just undo all of this like horrible crimes that I did like here. These ones, let's do them not greedy. So sorry, style not greedy is basically is going to, will it match ever? Will this match anything? I'm not sure. Hmm. So you've got this thing, and all I want to say is basically this can be anything. I don't care about that. So first of all, 2 patterns. That's not good. And then we should say greedy pattern instead of whatever this thing is. So let's just do this. 1, 3 groups. Not good enough. Oops, shit. That's actually 4. Sorry. Whoa. Interesting. So this one is actually 4. I don't know how that happened, but here we can see that we continue. We've got 4. No. So adding these dots actually managed to do something. And that is annoying. First of all, we can literally do dot star and dot star. We don't care about these. That's the whole point. All we care about is that this matches, these matches, these match. And this one must match till the end. And R1, continue, still 3. Oh, this one must match till the start. R1, just one group. Crap. I know that these are just crimes, basically. Dot star, dot star. And here we've got all of these things. A one, nothing. Okay, so first of all, we already have just one list. We don't need to do all of that. Just say length set of list. So having the star here is just fucking us over. So let's just not do that. And then that gives us 3 groups, and that's not good enough. Which one is the 4th group? So let's just do at pytest mark parameterize, and then we've got basically the pattern and the thing. So we could say that's going to be record and selected length. And then we've got, how does that work? Forgot. Okay, so arg names, arg values. So that's going to be a list of tuples of everything. So that's going to be just this thing. Let's try to add that. And it says that unexpected type. Why is that? It's the list of tuples. Why is this not the right thing? Oh, I see. Yeah. Okay, so now we've got our record and expected, and we should have a nicer way to look at things, which is to say L is going to be possible arrangements of the record. Then we can assert length of L equals to expected. And this would give us a nicer thing where, oh, type error that has no, okay, that is correct. That is correct. That's going to be, well, set. So set of theirs. And that's our thing where we say this is our range combos. Oh, and now we've got like locals and things and like that's actually nice. So yeah, that's going to make our lives way easier now to debug things. So that's going to be combos. And I wanted to say, let's actually have that as a sorted thing. That would give us like a reproducible outcome. So that's going to be a sorted set, and that's going to be a list of strings now. Be combos. So whatever we do, we know we are guaranteed to like have a nice little thing. So how are we approaching this now? So we've got basically not all of the options. So that's not good. By the way, let's actually flip these and also flip everything. No, that's that. Okay, that's. I think that's okay. So some of them are passing, which is annoyingly annoying. So are we overshooting in some of them? Interesting. So firstly, I want to drop empty matches. I think that's actually going to be very important. So I want to do this with I think find iter. That's going to be very important because we want to be a little bit more lazy. Then we do want to typer comparison not supported, for instance, regex match and regex match, because we are trying to sort. Yeah. So regex match, what is the rematch? What are the properties of this object? That's quite annoying. Import regex re dot match. Cannot create instances of regex match. So I just want to know what are things, and I want the dot string currently. Okay. Okay, so dot string. Nah, fuck that. Let's just do find all. Find all. Then what I want is to do something about these. And what do I want to do about that? I want a tuple of every group or group in combos if group is truthy. That's going to be in combo. That's going to be for combo and combos. Would this be good enough to move some of these things? Ah, shit. So first of all, I see we filtered out all of the empty strings, which is very nice. That means that we've got like more unique stuff, and we are still having problems with some things. And let's think about how can we actually solve this. So we know which tests are actually causing us trouble, which is nice. So let's actually run that with -- pdb. And then we are on, which is our record. This is the one. And we've got our combos, which is this one. Who's not doing, like, which of the, we should have two like combinations on each question, each pair of question marks. Which one is not matching twice? That's our actual question. So the first one is sometimes matched on dot question. One time is matched on dot question mark, and the other times not, which means it's the first one. So let's try to figure that out. So if we try and have here a dot question mark thing, or just dot, doesn't really matter, or these things. Would this continue? Continue. So this assertion still isn't correct, and we haven't got any better. Oh, interesting. It did change how we match things. Because it's not allowing question marks. No, that doesn't really matter. So this would never match anything, basically. Unless we force it to, which means it's not good enough for us. Dot question mark, and that's going to be a question mark because it's an optional one. And would this be kind enough for us to do the thing that we hope to see? And it's still not good enough. These three are still not matching. By the way, let's actually see test number 2, which is these two are matching twice. Why is that? Here we've got question mark, thing. Okay, so it's just not matching the question mark, which is not good. So, do we want to trim them into only matching things that are actually these things? Would this maybe actually fix our lives? So this one now matches. Let's actually, what was the pattern? So the pattern was, so the pattern was now only match this. So our record is now this case 3, 2, 1. So 3, 2, 1, and this now matches on 5 against 10. Let's look at that. I wonder if we already have the answer, and it's just like doing some small math of like combinatorics, basically. So if we look at the first one, let's actually look at the groups now. Which groups do we actually have? So we've got either this thing, which we know to be okay. So first of all, we are guaranteed now to have whatever's left, this is basically, this must be a spring, and then that must be a string as well. Yeah. Okay. So these all are actually guaranteed to be these are like actual arrangements, and then basically we've got to do the combinatorics of like the edges, only the edges. So if we now grab this span, let's just try that. So let's do another pattern, which is, well, nothing fancy, just let's match on all of that. With this, no, but this one won't give us like the inner combinations, maybe, I don't know. But let's try. So we've got this thing, find iter. And let's do a breakpoint here because I need to actually look at the combos manually at this point. So let's actually list them out. And let's run them. So we've got quit, run, and then let's see. So combos. So combos at index 0, that's going to be a match object. And its span is not the full span. So we've got, first of all, let's just do dot span just to make sure that we've got that. That's our method. That's going to be 113. And line, not line, sorry. What is it called? Conditions. So, and that's going to be, what's the length of that? That's going to be 15, right? 14. So that is matching right up until the end, not exactly, right? It's matching. So it's missing one dot on both sides. So how come this is the one that it's given? I'm confused. So we've got two things here. Each one is spanning a bit differently. So basically, okay, so we could now say, let's quit. So these are, let's just actually do this a little bit more cleanly. So import re as re if typing dot type checking import tree as import tree, basically. That would just give us a nice typing experience, I hope. So this one is now a list of match stir. That's very nice. So for this match, we do have our span. Interesting. Actually, like give the group a group, which is an interesting thing that I wasn't aware of. But we've got what's regs? Undocumented. Okay, undocumented, not touching. So group dict matches span. So end pause and well. I want basically to multiply each number by and choose whatever whatever's left of the match thing. I'm not sure if that's actually correct. Let's think about that. So if the span is smaller, does that actually help us? Let's look at the groups again. So let's run that again. We've got combos at 0. So this one and this one. One of them is, by the way, group dict. Interesting. Groups. Okay, so we've got the groups. We've got combos 1. Oh, there is no dictionary because we haven't done the thing which is like, yeah, never mind. By the way, which solution is this one? This is the what were expected. You don't have it, the expected here. Interesting. That's the first one. That's number 4, right? Station. Yeah, that's number 4. Ah, that's very annoying. So so why are we having things that collapse into being things? Python. All backtracking possible. All backtracking. Is there a way for me to maybe match on everything at the end or nothing at the end? Python. All possible overlapping regex match. So they claim that this whole thing where we say is in capture group inside the lookahead. The lookahead captures the text you're interested in, but the actual match is technically 0 width substring before the lookahead, so the matches are technically not overlapping. And this one says that the remodule supports overlapping, but it might not be all possible overlappings. So interesting. So we might actually do this. Aha. So let's try all overlapping matches within the group. So this is the group. Let's try this positive look ahead on the group itself, which is, say, positive look ahead on the thing. And then that's the overlapping matches. And we should do that also here and add it here. So these are going to be now all the non-overlapping matches. Let's actually do find all. And let's try that. Wait, run. So we've got combos. That's going to be just one match, and that's kind of annoying. 1 against 4. Why is this now not thing that we aimed at? We aim this to be. So let's also add it here. So let's rerun. Wait, run. Okay, so we've got things that have gotten better, things that have gotten worse, which is very much annoying. By the way, how is this looking? This is 3, 2, 1. Yeah, there's a lot of ways to like overlap that. So let's remove the breakpoint. I just want to run that. And then we've got combos, just one. Continue. Then 0, and this is a lot. So what's going on here? By the way, this is, well, since this is just like exactly one group, this might just be the thing. Oh, but then it's not a capture group, so we must have it in a capture group thing. So this must be, yeah, exactly, this must be one group long. This must be a thing. So what is this now? We've got a lot of like curses in regular expressions. So we've got we are only matching on question mark, question mark, question mark, question mark. Interesting. How come these are all like matching on the question mark? That's not possible. Or maybe it is. Actually, it is. Interesting. But not on the dots. So what gives? Let's actually import only this, the actual module, not. Okay. Yeah, I got it. I got it. And here we still need to find all the possible overlaps of. We do need like the dot star here and dot star here. And these are different groups. And this should be 11. Damn. So this is overlapping, then we need to okay, so we've got this one. Then we should have this one also here on the end. And by the way, I think this actually could be dot plus. I don't think there's an actual meaning to using the question mark thing. Basically, dot plus I think should work. Here we've got unbalanced parentheses. Unbalanced, yeah. So here we've got, okay, so we've got too many things that are, well, okay, interesting. So we might need to group things as the, okay, I think I've got an interesting proposition, which is the overlapping thing must be the one, like the thing with its separator. So instead of that, let's actually do it with So I've got an interesting proposition, which is to say, let's add, first of all, this mustn't be overlapping. I think this can be, or you know what? Okay, I'm gonna try to do things. Okay, so we've got this forward look ahead on dot plus and the count itself all together. And now we just need to balance our parentheses. Which means that first of all, this needs to have one balancing parentheses here. And this one needs to be dot star overlapping whatever and dot star overlapping here. Let's run that. Here we've got unbalanced parentheses in position 17, and we need to really, really carefully look at, let's actually look at the pattern. So, oh, we printed the pattern. So let's look at it. So we've got this one is balanced. These ones are not balanced. So that's the one. So we've got, oh, because we do need the opening one on this as well. So yeah, I think that's the opening one. Oh, so basically this is the opening one. And here we should have had another overlapping thing. Okay, let's try to rerun that. We still have unbalanced parentheses on lines 51. So 51, let's actually look at that. 51 is somewhere over here. So that's actually, okay. Ooh, that's nice. And this one is too much. So this one is not needed because, oh, because we already have a termination. Okay, that's very, very good. So yeah, okay. And now we don't need to capture this one anymore, I think. It doesn't matter. Then we've got, oh, that's not true, I guess. One isn't good enough. So len of, so how come this is so long? That's not good. Oh, because yeah, okay, so I fucked up. That should have been dot thing. And that also needs to be dot question mark. And this also needs to be dot question mark, just to be very, very clear. And we've got 4 groups. No, not 4 groups. Why is that? Wait, what? So this one isn't matching as we expected to. It's very annoying. Why is that? Let's add our breakpoint then, and let's actually debug the. Oh, I've got so matches, and then we could print these, and then we have anything we need, all we need, I hope. So that's going to be, sorry, find ita. And now we've got just one match which spans this thing. Let's try matches. Let's try to print all of the groups. So we've got m dot groups for m in matches. Okay, so the very nice. Let's do pprint dot whatever. Okay, so this is too much. Okay, so this must be lazy, non-possessive, but also must match the start. And this one can be whatever. Is that correct? That would be still have overlap between them, which is not good. Is this because of the big one, maybe? No. Because this one is actually matched. Okay, so let's look at the first group. The first group must contain, let's actually have it like so. So the first group must contain a 0 or more dots, 0 or more dots, and not dots, but basically like broken springs and question mark, like whatever, dots and question marks, and but also exactly this count. So this is one group. The other group is basically so we should have this amount of groups and just one tail end here. And the tail can be also overlapping. So let's have it also, but we don't have to match on it. Let's have it match because we want it to exist. Okay, so I think if I haven't fucked up the balancing, okay, so still not good enough. And what happens if we plus this one as well, which is equivalent to just having, okay, so let's, I'm gonna not plus that, but actually do this. And just have another like 0 thing here. As I tried before, but now we've got like a better like overlapping between groups basically. So no, but we must have, oh, I see, that's not gonna work because we must have the pattern like be overlappingly matching everywhere, but also between the combinations. So this is not actually what, like, this is not actually claiming what we want to, this is not doing the thing that we want to see. So how would we do that? So we could, instead of that, try to match every time and then like try to match all of the possible things. So let's do that. Apparently, we need to do that. So we've got this thing. So we've got counts. So how would we want to attack that? Let's just, I'm gonna copy this around and let's just try another solution, which is we've got a bunch of regular expressions. We want to basically find the overlap between all of them and then just cache everything. So how are we planning to do that? We basically want to grab this overlapping group and then do more things. Okay, so how does one group pattern look like? So one pattern is just given some count, which is an int, and it is also given a bool, which is first. That is going to return a re-pattern. And because repatterns are compiled, we don't need to do anything about that. But let's actually just do the functools cache thing just to be sure. So what one pattern is just going to be the so if first we do one thing, which is return, recompile, and that's going to be an overlapping implementation. So that's going to be this thing. Empty group, that's okay. We've got a group itself, which contains, if it's the first one, this needs to be started with dot question mark star followed by basically well, this thing, which is count question mark count. Else, same thing, instead of star, say plus. Okay, so these are our patterns. These ones can be cached, and that's very nice. So if it's the first, then we are doing this one because we want to also be able to like start matching on the first go. And we've got our one pattern. So for our line, how are we going to do this? We are going to so if our function, which I don't care about anymore, we do have line and counts. And we are going to return an int, which is the amount of possible arrangements or something like that. So we should say if not counts, we do something which is probably like return 0 counts. Otherwise, what are we actually going to do? We're going to say pattern is going to be one pattern on basically the first thing. That's going to be this one. Then we will try to match on that. So line, so that's going to be with pattern dot find iter on line. And for match in this thing, we are going to count 0. We're gonna sum that in a minute. We're gonna flatten everything and basically do that. So that's going to be return. Yeah, count equals 0, then return count. So for match, we've got match dot pause, right? Pause. So this is our start. So we would like to return, not but count plus equals f on line from the match position until the end, and with counts from 1 and onwards. And can we return the sum of all of these? So this is basically the length of things. Let's think about that. Wait. So this one always reduces into basically, okay, so when we finish, that means we do have a match. Okay, so I think that is it. So we can basically sum on f for thing for match in thing. We don't need to plus equals anything, so just return that sum. And we don't need to do anything fancy. We just say return 1. And we do obviously want to functools hash things. So we've got this, and let's start by printing everything. So line and counts. And let's try to run this f thing. So instead of this, we say f, just say f record expected. So we say counts. Oh, shit. So we do need this thing before. So this is the thing that we need to pass it the first time. So this thing is it's a list, and we do need a tuple. So let's call that tuple. And that's going to be record. And it says line not defined. Record. It says missing one argument first. Oh, okay. So how are we knowing this is the first? We also pass in the first argument here, which is true. And then have it will here. First equals false by default. And then here we do need to do that. And that's going to be cool. Going to be a tuple of ints. And that's going to be a sure. Then we've got assertion error. Ooh, that's a lot of assertions. So how are we going to dedupe a lot of things? Because we've got a lot of stuff. So we've got so by the way, we do want to like print the results, which is let's just extract that. So we've got result. And we can print everything in like one go. So we could say print line counts results. That would probably give us a lot of info to work with. So we've got that's not helpful at all. So the matching should have been through the end position. So that should have been from the start position to match. So from match dot end pose. And that might behave differently. So let's do that. We've got 0 equals to 4. Why is that? So this end position matches too much. So one pattern is counts int. Let's actually print this as well. So pattern print pattern. Oh, because the end position isn't actually, so we've got recompiled twice of the same thing. Oh, that's 113. That's actually sense, I think. How come we're never matching 3? Because we've never reached that area. And that's because we're caching and we're just passing the wrong thing. So let's actually also print everything here on the beginning. Yeah, so we're not modifying things correctly or something. Let's actually wait. The pattern is maybe it should have been slash dot. Let's try slash dot. And it's saying redundant character. Okay, so it is quite certain that this is actually matching the right thing. And the only thing that we're missing maybe is grouping things. So let's try to group things. And that is going to match probably something different. Wait, what? Warp. Python-m pytest. Module pi has now no attribute path. Interesting. If we activate the virtual lens and then we say just pytest, everything works. Okay. So where tuple equals tuple. What? So what's going on? I feel like this is not. So group 1, interesting. So let's try group 1. Group 1. Let's think about that a little bit more. Do we want to just maybe consume things and just do the thing without like this matching? Let's try maybe to just do this. Let's just return just the overlapping matches of just the group. Oh, but we do want the overlapping, just not that. Okay, so yeah, we can comment these out. Let's try that. So we do that, and then the group doesn't match the start, which means that we are able to start match from the end position, this thing, unlike the first one. And that actually consumes stuff. So let's try to run that. Maybe without PDB, let's just have errors be errors. So here we are consuming 3, 2, we are never consuming 1, which is always a problem. But also, we are seeing that we are still not consuming things correctly, which is not good. We've got matching on this thing, and because the end position, because it's an empty variable. Okay, so that is going to be group, like the second group, basically. And this one does need to have an end position. So how are we going to do that? We are going to unroll that back into a for loop. So let's split this up back into a for loop and then sum everything together on our own. So we've got for matching thing, then we've got a result, which is 0 at first. And we say result plus equals this function call, result, and result. Anything else? No, I wanted to do something with that, which is to print the match dot groups. And here we've got very interesting and curious thing to see is okay, so we are matching a lot of interesting stuff. But also let's print match dot start pose. Oh, sorry. Group one. Let's just do that. And what does group give us? It's a string already. That's not good. So I wanted like the start position of that. So how are we going to do that? Let's think about that. So we've got our line. We would like to advance until we don't match anymore. And for each one of these, we can try to dedupe. So what happens if we let go of this thing? We just have this find iter thing. And that's not good because we actually just want to consume exactly one. Okay, so that's not good enough yet. Not yet. We've got, oh, maybe this. And then we want to match on the second group. So this one will give us all overlapping matches of the first count. And then anything after that is going to be the second group. That's the one that we actually want to do. So this needs to be possessive as much as possible, which is very good. And that is going to actually have a start position. So let's do this. So start at pause. And let's try that. And we've got more behavior. That's very interesting. So we've got 3, 2, 1. And then we matched on 3 dot dot. That's actually correct. Then we passed it down, and then that didn't work because this still matched on so match.pause doesn't do what I expected to. Wait, let's just do that. So match.pause. Let's look at it. So match.pause is 0, and that's obviously wrong. And how does, so we've got the groups, and the groups are, the first group is this, and then it's not doing the thing. Oh, that's not good. And what happens if we also say, so this is now going to be the same pattern, basically. But now we are going to actually match it. So the same group, oh, we could try \1. That actual group, and it says group 1 and this back reference are in different branches. I'm okay with that. And it says that no. So let's just have that as well. So we can say pound or 12, and that's going to be and count. Would this work? And now we've got our thing. And then so I really want oh, we actually know like when oh, I know. Okay, so it should be plus counts 0. That's the thing. Basically, it says if we matched it, then we need to advance by that amount, and then we don't need this whole crazy double group thing. Then let's try that. I just and we've got crazy ass numbers. And why is that? So let's look at everything. So what the hell is going on? So this is basically we have matched on the first group. So yeah, so this is not going to work because we need to also like not consume things that are behaving like that we will consume on the other patterns. So what else do we want to do here? Because this is not yet everything that we need. So we want to say counts is a tuple of ints. There is no first, but we do want to basically split everything. So if len counts equal 1, then we just return this counts 0. Otherwise, oh, and if what are we doing when we reach the bottom? Oh, it's okay. We are guaranteed not to be called with this. So that's now going to be first and rest. That is going to be now counts with them. Then we are going to return a recompile of the first one, is the same pattern. So that's going to be the first. No, so we actually can join that. So let's think about that. How would we want to join that? We would want, well, recompile rf string. And in that string, all we want to say is dot question mark plus, then that's the separator. And we would like to join that. Can we join that easily? So pattern join, just so we'll have like the nice syntax highlighting basically. Recompile rf. Oh, here we don't actually even need the formatting. And this one should be so the file of pound question mark and this thing. Rf for count. in rest. So wait, do we need to do that? We can just literally do this. So that is just going to be all the counts. So when it's the first one, we don't need to do anything. That means also that this actually, oh, but the first one actually, okay, so the first one has a special job, which is to match and beat and do the whole parallelizing, and not the parallelizing, but the overlapping thing. So that needs to be rest. Then that needs to be then, that's the case. We've got that. And this one is not joining on the thing. We need to join on strings. And this one isn't really, yeah, let's just do that. Don't do all this recompiling thing for nothing. Okay, so we are joining on the right thing. And all we're missing is to say tail pattern is this thing. And we are missing one more thing, which is the first separator. We could say this, that's the first, and plus a tail pattern. So now we've got all the things that we need. Okay, so I think that's actually going to match on the first one and leave us with whatever there is there. And are we doing the match pause plus count? Okay, that's very good. So that's going to be first, and these are all the others. So let's try to run that and see what we're getting. So first of all, we've got typer, which takes one position argument, two are given. And we go here, we say there is no call for first. We're actually not using that anymore. And there is no first here. Okay, so typer again. Object int has no length. Where are we saying length? Counts. Why is this int? Because we haven't passed in all the counts. Okay, legit. And we've got one test that passes, but the others aren't passing, which is very annoying and very interesting. So let's take the first one that fails, which is this one. Every time this one fails. So we've got this failure. We are passing. This is the string. This is the tuple. Then we have our pattern, which is recompile, matching, overlapping on the first one. And we are getting the question mark and double question mark. Why is that? Yeah, that is actually correct. And then we're getting, okay, I think I need some, like, okay, so we've got pattern. Then we've got print match, which is match pause. We got match. And then pause, pause, pause. I'd also want the match groups. And here we've got basically line counts result. Okay, so what else are we reprinting? So here we've got entering line counts. Okay, so we are entering line and then we are getting these counts. Our pattern is going to be the overlapping implementation of this thing and then all of the others, which are basically should be the greediest matching thing, basically. And then we've got two groups, which is the all of these and this thing. Entering line. This is the next parent, the next match. So interesting. So okay, entering line. How come this is the match and this is the groups? These are the groups. I'm confused. So is it groups plus 1 plus 0 plus the thing plus the size of the group? Pattern recompile. So match pause on 3. Since this is the thing, yeah, this actually, okay, this slices correctly, but why haven't I seen? Okay, I mean, because of the 0 width. Okay, so the first group is basically garbage. And that's okay because that's the point. It's supposed to be garbage. But then we've got counts 2, and this is the combination that we've got. So we are recompiling now with 2 and then only 1. Then we've got line question mark and just count 1, and this should have been the most overlapping crap, and that's okay. That's the most overlapping crap there is, and that's going to be result 7 things to do. That thing is going to be exactly 7 instead of what? Okay, so why is this matching only once? So this, where's the separator? Let's do that. Let's do that. Now, let's run that again. We've got 28, which is way too much. So somewhere in the middle lies the truth. So if we've seen it, we don't want to count it again because it's the same thing. So that needs to be not cached in that sense. So how are we going to pass this, the whole, like, if we've seen it, let's not do that again. Right, because we've got basically print intermediate result. Oh, I might need to leave in a few minutes. So we need to figure that out. Okay, so we've got intermediate result of 1, 2, 3, 4, 5, 6, 7. That's okay. And then we've got an intermediate result of 7. Then we're doubling for the wrong thing. That's not good. Yeah, so basically that means that if this one is cached, we don't want to count it again. We just want to not do anything about it. So instead of caching like that, do we want to actually like see, like say seen and like not do anything about that? So let's apparently, yeah, let's just pass in a cache that's going to be a dictionary. And we should say if, okay, so first of all, what we want to say is basically, okay, so cache dot set default 1. Not like that. We want the key, which is, okay, so key is line comma counts. That's our key. So yeah, cache equals cache or empty dictionary. Then we say cache key 1. Okay, so this is our set default thing. And here we need to say, well, we need to pass in the cache. So yeah, if key and cache return. That's it. No ints here. Going to be none. That's a, you know, we can return the int. Wait, why not? Return 0. That's not cache, that's visited. And that means that subsequent calls for the same thing won't be anything fancy. They will just would return 0. And we do have like 3 minutes. So let's just try that. And otherwise, that's going to actually plus equals this. And we do want to say hash sorry, visited at key equals sorry, yeah, so visited dot set default dot, and let's run that. And this would possibly fail. Unsupported type, and it says plus equals for int equals. And why is that? Int and type. Does that not return the type? Interesting. So okay, so So not self, but just visited. False one. Could be actually a set. We just need to basically not visit things. Okay, so if we visited, return 0. Otherwise, we are actually counting this one, and here we should say the same as visited at key equals result and return result. On that. And we've got 28 again, and I don't have the time to do anything about that. I need to go. So yeah, apparently this one waits for the weekend. Bye bye for now.